Someone did get locked in there. So in the spirit of talking about our backgrounds a little bit, one of the things that I'm often asked, particularly when I talk with people in the deaf community, is how you got interested in sign language and deafness. So for me, because a lot of people have a deaf person in their family, or they know a deaf person, they get interested in sign language that way. I got interested in it basically through the science. So my PhD was was in linguistics at UCLA. I knew nothing about sign language. I was looking at morphological parsing with auditory presentation. And I did a postdoc at the Salk Institute with Ursula Bellugi, doing one of these wonderful NRSA proposals that you can do through NIH, where you have a particular expertise as a graduate student. So mine was in sort of psycholinguistics and neuroscience, matching with the expertise at the Salk Institute, which was sign language research. This was the main place to do sign language research in the United States. And so I started working, doing some of the first psycholinguistic experiments using sign language and comparing sign and speech. And I got really hooked because I realized, wow, you can ask a lot of really interesting questions about why language is the way it is, about the relationship between language and other cognitive systems, about the neuroscience of language, by looking at sign languages, by using them as a tool to probe the nature of language and its neural underpinnings. So that's kind of my background of how I got into sign language research. And what I want to do today, since this is talking about the neurobiology of language, is think about the biological differences between signed and spoken languages. So clearly we have different linguistic articulators. So for sign language, the primary articulators are these large, instruments, the hands and the arms. For spoken language, it's very different. You have the vocal tract, the tongue, the lips. Those are coordinated for speech. So you can look at what ramifications do these differences in articulation have for various for cognitive systems, for the neural underpinnings of language. And of course, we also have differences in the perceptual comprehension systems. So sign languages are perceived visually, spoken languages are perceived auditorily. And I want to kind of look at the nature of these biological differences and what they can tell us about the neurobiology of language. So I'm going to start first by kind of talking first about the generality of the language faculty. So looking at parallels between signed and spoken languages to kind of set up the rest of the talk, which is going to be looking at some of the differences and what their ramifications are. But I think we first have to start with an understanding of the parallels between signed and spoken languages. And then I'm going to look at 3 domains where we see some differences between sign and speech. So one is looking at the interface between perception and production, which has been mentioned a little bit already. Looking at the nature of spatial language, so the interface between language and spatial representations, and the interface between language and human action, which is quite different for sign languages compared to spoken languages. And again, these stem from the differences in the biology, the fact that languages are produced with the hands that can move in space, the fact that you have a visual perceptual system as opposed to an auditory perceptual system integrating with your linguistic articulators. And please interrupt with questions as I go. Okay. So I'm going to just start with what I think is one of the really fundamental discoveries about sign languages that was made about 40 years ago now, which is that signs have parts, okay? That they're not holistic gestures. So just as spoken languages, words can be divided up into segments, so consonants and vowels, meaningless in and of themselves, they combine to create the lexicon. So for sign languages, you have a similar kind of system. Of course, it's not consonants and vowels, but the units are things like hand shape, different hand shapes. You can have hand shape inventories that differ across sign languages. You have placement of the hands on the body, so you have place of articulation. And you have movement, as well as orientation. And these different units get combined to create signs. And what's particularly fascinating, I think, is that some of the linguistic mechanics or architectures that have been used to try to explain phonological patterns in spoken languages have been applied successfully to signed languages. So I just have a couple examples here. So one is optimality theory, which is basically a theory of constraints on phonological form and ranking those constraints to predict what's a legal form and what's an illegal form. This has been used to try to describe sign language structure as well, and to explain, in this particular instance, how signs are borrowed and how they change to conform to the phonology of American Sign Language in this case. The bottom one is just an example of feature geometry. So that's one model that's been used to describe assimilation processes in spoken language. So you have a hierarchical structure of the articulators, and you can show how you can have assimilation, one form becoming more like another, based on the geometry of the articulators. This has been used to explain the same kind of thing in sign languages. This is an example from Israeli Sign Language, where you can see delinking and associations within the sign system based on hand shape in this case, rather than things like voicing or a place of articulation for spoken language. So it's fine for linguists to sort of describe these things, but do we have evidence that these are actually in the minds of signers? So is there evidence for psychological reality that you have these units that have to be assembled, for example, during language production? And evidence for that comes from slips of the hand that are parallel to slips of the tongue. So for spoken languages, looking at speech errors has been very fruitful in understanding the units of speech and showing that they are actually assembled during production. So they can be misselected, they can be transposed, perseverated, anticipated. And the same thing for these different units that have been identified for sign languages. So this is an example from a group looking at German Sign Language, showing an example of a sign error, an anticipation error in this case, of hand shape. So what he wanted to sign was his parents, okay? But he anticipated this Y hand shape and produced this, okay? And there's a lot of different kinds of examples where you can have swapping of hand shapes, you can have anticipation of locations, you can have perseveration of movement units. And so the same kinds of misselections happen for sign production that happen for speech production. And what this is telling us is that signs are not holistic gestures. They really are composed of these parts so that they can be misselected during production. Okay. So this was nicely set up for me by Dick Aslin on Monday. So these units are not only important in production, but also in perception. So what's been found for spoken language is this idea that you become perceptually tuned to the units that are in your language. We find the same thing for signed languages. So this is a categorical perception experiment where we, again, just as you do in speech, where you have a physical continuum that differs by the exact amount. Here we have a creation, computerized generation of a change from a B hand shape through equal steps to an A hand shape, okay? And it's hard to see this little curve here, but you get the same kind of sinusoidal labeling function that Aslin was talking about. So there's a particular point where everybody is saying, okay, this is a B, and then about 4 or 5 along the continuum, people start labeling it as an A. So you can see where the category boundary is. And it turns out the category boundary for signers and for non-signers, hearing people who don't know sign language, is about the same. But what differs is the discrimination. So this is the key to the perceptual tuning idea, that you're better able to discriminate same, different when the two hand shapes straddle the category boundary than when they're within the boundary. And that's what this bottom little graph shows for the deaf guys, for the signers. That peak occurs right at the category boundary. And for hearing people, I don't have it plotted here, but it's pretty much flat. So they're insensitive to that category, that boundary. But the signers are better able to discriminate across the hand-shape boundary. Okay? And it turns out, this is, it's too bad Janet's not here, but this slide is for her. She recently published work looking at the development of this perceptual fine-tuning for signers. And it turns out that if you test on a discrimination paradigm with infants, this was looking at this 5 hand shape to a 0 hand shape or a flat O hand shape. They used movies in this case and naturally generated video, but the idea was still getting this continuum of equal changes. If you looked at kids who were not sign exposed at about 6 to 9 months, they were sensitive to this categorical boundary. So they were better able to distinguish across the category boundary than within. And then later, this is about 12 to 14 months, the babies who were not exposed to sign language lost that ability. But the kids who were exposed, so either deaf or hearing but had signing parents, maintained that ability and were able to discriminate better across the boundary than within the boundary. So it's very parallel to what we see for fine-tuning for speech. You see fine-tuning for the units of sign language, the phonology of sign. And just as an aside, also, just as it's not uniform in spoken language, where you see less categorical perception for vowels compared to consonants, it's similar to in sign. We see more evidence of this within hand shapes than within location, which can be more gradient and variable. Okay. So actually, let me go back one. I just want to say one more thing about, so I've been showing you parallels between sort of phonological assembly for production, fine-tuning and perception. And actually, I just want to point to Emmorey, who'll be talking a little bit about the neural underpinnings of phonological processing. You also see parallels for sign and for speech, and Emmorey will be talking about that. So what I want to move to just next is I'm showing you sort of psycholinguistic parallels between sign and speech, at least at the phonological level, which I think is the one that's the most surprising, right? Because that's where we might think we'd find the most difference, is at this level of form as opposed to, let's say, at the level of syntax or word structure. So when we look at now just the neural underpinnings for sign compared to spoken language, we see the same basic key regions of the brain that are involved. In this case, this is looking at signing and speaking. So the top one is a PET study looking at picture naming in deaf ASL signers who are native signers. One of the things to know about work looking at signers, deaf signers, is there's a range of times at which a person might learn sign language. So if you're born into a deaf signing family, you're going to acquire sign language from birth. If you're born into hearing family, you may not get exposed to sign language until much later. Almost all of the studies in fact, all the studies I'm going to tell you about are looking at native signers, because we're particularly interested in comparing the neural underpinnings for spoken language and sign language. And so you want to compare apples with apples. You want to compare. So for the speakers, they've acquired English from birth. You want to look at signers who've acquired sign language from birth. And I think you'll probably talk a little bit about late signers in your talk.
I won't mention the data, but I'll say about it.
Okay. So anyway, so the top slide there shows, in particular, you can see the conjunctions. So these are regions that are active for both speakers producing single words and signers producing single signs. And you can see that this left IFG, Broca's area, is equally engaged for both sign and speech production. So even though that this region is really just anterior to the sensory motor control of the speech articulators, despite the fact that you have very strong connections between Broca's area and auditory cortex, we still see that this region is involved in the production of a visual manual language. So it's really a language area, not a speech area. You can also see there, you see this left lateralized inferior temporal activation. So this is a region that is hypothesized to be involved when you're, particularly for picture naming, when you're mediating between object recognition and lexical selection. Both processes that are involved in word production and in sign production. So the bottom slide is from a study now, not of deaf signers and hearing speakers, but of ASL English bilinguals. So these are hearing people who are born into deaf families who acquire ASL and English as first languages. And so you're looking at the production of sign and speech in the same individual. In this case, looking at spontaneous narratives. So these guys were in the PET scanner and asked to produce narratives about their lives in either ASL or in spoken English. And what you can see is in particular anterior regions, left lateralized, frontal regions active for both sign and speech, and you see more bilateral posterior regions involved for both sign and speech. So you find really clear overlap between the two in these kind of language regions. And particularly for the posterior bilateral, regions. For this kind of narrative production, you're doing a lot of semantic processing. Both hemispheres are involved. Okay? Okay. The same thing for comprehension. So one of the things that's important when you think about comparing the comprehension of sign language and the comprehension of spoken language is what type of spoken language are you going to present? So an early study looked at reading, because it's visual, compared to sign language, and found that reading was much more left lateralized than processing of sign language. But in fact, it was Murray who pointed out with this study that really that's not an appropriate comparison, because reading is learned, it's learned late, and it's very different than online natural language processing. And actually also just comparing it with a disembodied voice is also not the same comparison with what you do when you're comprehending a sign language. So sign language is always face-to-face. So if you really want to compare the neural systems that are engaged in sign language with spoken language, you need to use audiovisual speech. And so these are two studies, one with British Sign Language and one recent one with American Sign Language, where we have, in the top one, this is two subject groups, so BSL signers, native deaf signers, and hearing English speakers, looking at the conjunction for comprehension of sentences in either BSL or in English. And the bottom one is, again, this bilingual group, so it's within the same person, comprehending signed and audiovisual speech. And what you can see is, first of all, it's a bilateral network with greater activation or more extensive activation in the left hemisphere, but classic language areas. So we see this posterior superior temporal regions, and both are engaged in sign language comprehension. So this is kind of the classic Wernicke's area. And so you see this region, even though it's kind of in secondary auditory cortex, you're still seeing it being recruited for sign language comprehension, even though that information is coming in through the visual system. Okay? All right. In addition, people have looked at ERP responses for sign. So this is a relatively recent paper by Cheryl Kapek, looking at basic semantic violations in ASL. So this is the classic, you're listening to or you're seeing a sentence, something like, I take my coffee with milk and dog, and when you get dog, you get this N400. The same kind of thing you see for sign language. So you see the same ERP component responses for semantic violations in sign language that you see for spoken language. In addition, you see the separation between semantic violations and syntactic violations. So if you have a particular violation that's been termed verb agreement in ASL, you get this P600, which is linked to either semantic errors or error detection. So this is an example. The sign, I don't think I have my notes here, but I'll just sign it and see if you can tell which one was correct and which one was the error. So can you tell which one? So one had a verb agreement violation where the verb went the wrong way. So this was a sentence that meant basically every day or every week I wash my new car. And in the violation, the verb wash is like the car is washing you. So you have a reversal of the verb. Or you can do the same thing. You can set locations up in space so that the mouse is chasing the cat, and then in the violation, you have the cat chasing the mouse. So you have a reversal of verb agreement. And that causes this P600 response. Okay, so very parallel. So what I want to conclude first is that all human languages evolve a level of meaningless sublexical structure as well as sublexical structure. So in David's terms, sign languages have the same parts list as spoken languages. So the same types of syntactic structures that you find in spoken languages you find in sign languages. So you find embeddings, you find recursion, you find variation in word order across sign languages, At the morphological level, you find the similar types of morphological information being marked, so things like aspect, tense, other kinds of compounding, all of those same kinds of processes you find in sign languages. In addition, neither one of us is going to talk about language acquisition, but as you've seen in the one little bit I gave you in terms of perceptual tuning, you see parallels between the acquisition and of signed and spoken languages. So we see the same basic milestones that have been documented for the acquisition of spoken language. So the onset of first words at about 1 year, first word combinations, you see babbling, and the type of babbling shows links to first words, so it's a clear, the types of handshapes you see in the babbling, you see in the first signs, just like the types of sounds that are babbled appear in the first words. So these same kinds of links you see in both signed and spoken languages. So acquisition seems to be pretty parallel. And we see these sort of key brain regions, left lateralized. Frontal regions, temporal regions are engaged in sign comprehension and production for both signed and spoken languages. Okay, so before I go on to the differences, do people have questions just kind of about the general comparisons between signed and spoken languages? Mm-hmm.
I'm curious about the frontal activations that you see, and obviously if you were to go back to the presensual gyrus, the motor strip, the somatosensory strip, they'd be very different locations involved in producing signed and spoken languages. You don't see any hints of that in, say, the difference between inferior frontal and middle frontal activations when you're that bit further forward.
Not in those kinds of comparisons, in part because of the baseline, the contrasts that are done. So often, both in the Brown study and the study that I was doing, you subtract out a baseline task where you have a motor response. So you're getting rid of the low-level kind of motor responses. But in fact, when we do a direct contrast, so there's a paper that just came out that looks exactly at that issue where you get a direct contrast, you do see then differences along the motor strip. You still see the conjunction in Broca's area, but you see this differential activation in the motor strip.
You present a conjunction, but that's not really a test for whether there's a dorsal ventral shift in the center of mass of the activation.
That's true.
It's showing that there's overlap, which I
Yeah.
find compelling, but you might still get a dorsal ventral shift because of the different locations on the motor strip.
That's true. There is one study that might speak to that a little bit. So David Carina did a cortical stimulation mapping study a while ago with one deaf patient and mapped the motor movements for the lips, and then also stimulated just anterior to that and got articulation changes in sign production. So it's not quite the same, but yeah.
That also makes me think, don't you do use your face during signing, and don't you also use your, don't they often say the words or in other ways use their mouth as part of this, so maybe it's not so different. Maybe the motor activity, and given that people are gesturing when they speak, maybe the motor activations are not that different.
No, that's a really good point, because it's very true that, I mean, it can vary across individuals and across sign languages, but you tend to have mouth movements of various types that accompany signs. So you have something called mouthings, which are borrowing from the spoken languages. So when I said in my example, I mouthed this, and that's typical. You can have something that's obligatorily accompanies a sign, but it's not derived from the spoken language. So in ASL, the sign, which means finally, at last, or success, this pa opening is required. So it's part of the phonology of the sign.
Related to that, is there something like the McGurk effect in sign, particularly when you are making kind of articulate gestures that could be misunderstood if you do? Is there another thing that is like this, but with a different mouth opening that could, I mean, you will have, I don't know if you can construct one.
Well, the McGurk effect is an integration of auditory and vision, right? And so that you don't have something like that. It's all in one modality. So you can have something about integrating mouth movements and hand movements, and those are timed. right? But you don't, the effect of getting a different percept doesn't exist. But you definitely have to,
That has been looked at because, I mean, that's why I'm asking, because you could construe that this is both in the visual domain, but those are really different aspects, and that if they're incongruent, that you would have a third percept. That would make it then very similar.
but the third percept for the McGurk is because the vision and the auditory thing are not matching. That's why you get the third percept. And this is all in the visual modality. So maybe I'm missing what you're...
Yeah, but if the mouth gesture is not congruent with your hand gesture,
Then it's just perceived as a misarticulation, right? So if I do the wrong thing and I go instead of pa, it's just like a weird sign. You don't get it.
Voice onset time differences, where the timing of the larynx and the lips is very...
unless you have gestures that could then, just like the B and you could imagine that you have signs that are ambiguous as a result of mouth and hands not going together, not being read as a mistake, but being read as a third percept.
You don't get the third percept, but you can have disambiguating mouthings. So you can have mouthings that if you have one mouthing, it means one sign. If you have another mouthing, it means a different sign. Okay, I think I may be missing what...
Can I just, sorry, before David says anything, can I just invoke again the discussion we had yesterday about nations' rule of law, which is that we'd like people under 40 to speak up first before we bring in all the older folk. So
Whose law is that?
it's Cape Nations. Is that right? I don't know.
It's now a law.
It can't become a law.
It's a
rule.
Sorry, I've turned it into something completely.
We had it.
All right, so do we have any under 40s who would like to...
So if any of our more junior members
Instead
want
of
to
a
ask
question,
any
I
great
can make a comment perhaps, because I am aware of N400 components, so when there's a mismatch of the expected meaning and the gesture you produce, so this is the same with spoken
Yeah.
language, right? So
Yeah.
and also with sign language. So apparently these are quite different, because when you use the verb in the not correct direction, then it causes P6.
But that's a syntactic violation.
Yeah.
Right? So if you have, I mean, you might get a...
Like when you do, how was it? I don't know.
Pa.
So maybe, when you already start this, then it causes an expectation of pa, but then you do something else. So then there's a mismatch.
That's right. That's right. The thing I'm arguing with, Constance, is about whether there's a third percept. There's certainly a perception that there's a mismatch that's perceived. But whether you get a McGurk kind of thing where you fuse two inputs, you have to have the visual and the auditory to get that. That's the thing I'm taking. But you definitely get a mismatch, and there's definitely timing between the two.
I'm a felt 28.
That's in basic.
I see.
Behave poorly, but I'm a felt one. So the mouth information is different in the sense that it's completely correlated to the acoustic signal. So if you, for instance,
That's right.
quantify the amount of opening, it correlates with aspects of the envelope in certain bands and so on.
That's
So
right.
I think the question, if I understood Constance's question, is the kind of, is the face or mouth information actually a different kind of signal? Not just a correlated articulatory signal, but just some feature, and then there's some other feature. And they could be mismatched to generate an independent percept. It's not just a correlation, in an information theoretic sense, they're not as redundant. It's a different kind of
That's
thinking.
possible.
It's really
Yeah, I see what you're saying. I see what you're saying.
So David, would you kind of test with, say, if I understood it correctly, we could kind of test that by using the visual information instead of the mouth moving, you're using some kind of sign in parallel with the sound, and you somehow match that, I guess. And then
Well, there's no sound, of course.
But like a way to test if, I guess the idea is, if you could imagine a situation in which you have the sound and the gestures kind of matching in some, I don't know, it probably doesn't exist in a situation, but like in one scenario in which people communicate using both, and kind of in a sort of redundant way, then having the mismatch between the sound and the hand gestures rather than the mouth movement, that could kind of replicate that. assessing what you're trying to say. There's something special about the mouth information movement. No.
Well, so part of the McGurk effect, though, isn't like we have a causal understanding and expectation of mouth movements and speech, like auditory information. So even if you have a hand gesture and a sound paired with it,
No, but I mean,
there
this
isn't
is-
necessarily a causal
There's no
relationship there.
Yeah, right. Yeah, there you go.
But what David said is exactly what I'm saying. You could, whether it can
The
be
time.
tested because there is a mouth movement and a hand movement that independently or in one constellation are congruent and another constellation are incongruent, but not just an error, but would.
But that's the key is that what follows but. They're not incongruent, but, right?
Well, that depends. It's hard to know that without knowing sign language, whether you could construe a situation where your brain is using that information to make a third percept instead of saying this, because I mean, we could, in the McGurk, we would also just say, this can't be. You know, the mouth and the ear is not matching, but our brain is not actually saying that, but making something third out of it because we don't expect that. And you could, with a signer, you could argue the same thing, that a signer would not really expect an incongruent mouth gesture with a different with a hand gesture, and therefore integrate them into a third percept.
And I guess that has been tested, and my gut would tell me it doesn't happen, but we'd have to think about the right way. And in fact, maybe the next part of the talk is related a little bit to that, only because we're going to be talking about the relationship between perception and production. But.
And totally un-McGurk question. So I'm wondering, I find it curious that the language acquisition trajectory is the same, in part because you need to split your time in the same modality. So if you're learning the word bottle, you have to both be looking at your mom making the sign and looking at the bottle.
That's exactly right.
Referred to. So I'm wondering if we know anything about so it can't
We
just
do.
be, yeah, please.
Yeah, so that's great. That's exactly, I think that's a fundamental difference, in fact. And because there's consequences, right? Because if you don't have joint attention of the baby and the mom or whoever is both looking at the bottle and saying bottle, if you don't have that kind of coordination, there's vocabulary delay. So we don't see vocabulary delay in deaf kids, and yet you've got to get everything in the same modality. And part of that is the strategies that deaf caregivers use to get the language and the visual world in the same modality. So there's all kinds of strategies. They're very sensitive to where the baby's looking. So they may wait for the baby to look and then sign. They may displace their signing. So motherese has these really unique modality of properties that you don't see in spoken language. So they'll displace their signing, so you'll get bottle next to the bottle. They'll sometimes sign on the baby. So there's a lot of ways to make sure that the language and the visual world are in the same visual field. Hearing moms have to learn how to do that. So they often aren't attended because they're just not visual people. They are used to sort of hearing strategies, and they have to learn those visual strategies. But that's a great question.
Following up on that, is there the equivalent of motherese? I mean, so that's in a sense a form of motherese, but it's very different from spoken motherese. But is there also sort of exaggerated and repetition and all those phenomena also appear?
Yep.
And what about in hearing mothers? Is that only in signing mothers, native speakers?
Oh, that's a good question. I don't know. I think most of the work has been done looking at deaf moms. Do you know with hearing moms if they do the same kind of motherese stuff?
So Gary Morgan is, so at UCL we've done Gary Morgan has done a little bit of that recently with deaf mums who definitely do it, and then with hearing mums who are learning sign language as well. And they appear to do it a little bit, but it's much more conscious, they're much more aware that they're doing it, and it's kind of teasing apart. They've been told to do this in their sign language class or whatever, but deaf mums do it.
Yeah.
Is it deaf moms who've been raised by deaf moms also, or just deaf moms who might have learned sign language who maybe had hearing parents but learned sign language from early exposure in schools?
I'm sure that it doesn't have to be third generation deaf. I'm sure that it's deaf moms who have hearing moms, but they're deaf. They've grown up deaf. Only because of the statistics of what this research would be done. It would be done with just deaf moms who have hearing parents.
I know nothing really about sign either, but I was just away on that spectrum to shift to some kind of intermediate.
To shift the percept of the hands?
Yeah, so I don't know whether this is the case at all in sign language, it probably isn't, but if there are some signs that have both a small amount of movement of hands and a small mouth shaping, moving towards largeness of both, and if you were to shift the mouth in one direction away from the hands.
Yeah, I just don't think the mouth and the hands are that tightly linked. So, for example, there's a study looking at slips, slips of the mouth and slips of the hands, and they slip independently.
Right. Okay.
So they've used that, particularly for mouthing, used that as an argument that that deaf people's representation of mouthing is really speech-based. It's not necessarily part of the sign representation. So they're two different kinds of things. So, but yeah.
Just have a really quick question. Sorry, just about making stimuli, which is that it's it's not easy at all to synthesize speech, but it's even harder to synthesize fake signs. I mean, if anyone's seen an avatar, you know how weird it looks, let alone then making it do strange things with its hands.
Yeah.
So the stimuli look really weird when you try and generate.
Okay. Yep.
Is there a parallel phenomenon of stuttering in sign language?
You know, can I hold that off to the next part, only because it's kind of related to that. But don't let me finish this second part without coming back to stuttering. So, all right. So now what I want to look at is this difference between the interface between perception and production. And why do I say it's different? Oh, actually, I don't have where I'm going next. So, okay. So I want to frame this in a model that's recently been proposed by Greg Hickok, but is also very similar to Frank Gunther's DIVA model. And so I want to focus on. So you see here, this is a neurally instantiated model of speech production. You have motor systems on the left and the auditory and perceptual systems on the right. And I want to focus on the circled areas here. So this is the relationship between acoustic auditory feedback feeding into syllable targets. So this fits with Tara's talk, where the idea is that there's acoustic or auditory targets that you're trying to reach, and this particularly plays a role, at least in Gunther's model, of building up the system so that you're using feedback to help train your articulators to produce particular sounds, right? Now, if we switch this to sign, okay, we're just adopting this, and we've got now different articulators, the fingers, hands, and arms. You've got now visual feedback from your signing. I'm not going to go into whether or not there's a distinction between segments and syllables, so think of that as one kind of lump there. I can talk about it if you want. There's evidence for syllables. They don't seem to play as big a role in the phonological structure of signs, but it's kind of irrelevant for what I want to talk about. But the question is, you know, are there something like visual targets of some sort? Okay? And why is this an interesting question? Well, it's because we have this difference between the visual feedback that you get when you're signing yourself and the visual information that you get when you're comprehending someone else's signing. Okay? So signers don't look at their hands, okay? They don't look at their hands, they look at their interlocutor. So what I want you guys all to do is make the ASL sign for 9, which looks like this. Okay? All right, now think about, you're looking at me, you're talking to me, right? What input you get for the comprehension system, and what visual input you're getting from your own productions, okay? And it's different. So when I look at Dorothy, first of all, I see her face, and I see a smaller image of her hand from this direction, but my own hand is in the periphery of vision, it's bigger on the retina, and it's from a different angle, right? So that's quite different from for speech, right? So the acoustic input that my comprehension system uses to understand someone else, I can use that for understanding my own speech, right? I mean, there are differences, but if I just listen to myself on a tape recorder, I can understand myself perfectly well. But we've done some experiments to see how well do you understand the visual perceptive self-perceived signing, and not so good. Hands fall outside the visual field. So it's a problem. And so one question is, you know, what is the visual target? So one of the things that we know, auditory feedback, as I said, is used for in...
Why does the target have to be visual?
It doesn't have to be. It doesn't have to be. I'm just questioning. So if there is a visual target, what would it be? What would it look like? What would it look like? And So we know that auditory feedback is used to fine-tune articulations in speech. So we wanted to do an experiment to see whether or not you use visual feedback to fine-tune sign articulation. So to do this, we had 2 groups of people, deaf ASL signers and hearing non-signers, learn to produce Russian signs. Now we included hearing non-signers because they don't already have a sign-based phonological system. So it's possible that they even depend more on visual feedback to fine-tune their articulations. And in this experiment, what they did was they, everybody had these, well, it was in 3 conditions. You had clear safety goggles, so you got visual feedback. Or you had blur, they were super blurry, or blackened goggles, so that you were blindfolded, basically. So you would see the sign that you would have to produce. Then you would lower your goggles, and they were either clear so you could see, or they were blackened. And then you produced the sign, raised them up, looked at the next, repetition of the same item, tried again, and you got to do this 5 times. And your goal was to try to, imitate this Russian sign as much as possible, as closely as possible. We made it even trickier because, of course, in sign you have mouthings, as you all know now. And so you not only had to imitate the mouthings, but you had to imitate the sign as well, because we predicted no effect of the goggles on the mouthing, and we didn't find any. But the question was, what do we see in these different visual feedback conditions for sign productions? So I'm going to let you guys try. So you guys all ready? Okay, so I want you to imitate this first sign. With the mouthing, remember. No, pretty good, pretty good. Yeah? All right, let's try one that's a little harder. Now you would have gotten 5 more tries at this. And so remember, you either did this where you could see your own visual feedback or you were blindfolded during your own productions. It turns out, as you'll see, there wasn't one, but we were just looking at degraded vision. So it was like you had 2800 vision or something like that. So it was pretty blurry. So in the end, the blindfolded and the blurry wasn't different. We wanted to see if we got a gradient kind of effect, but
These were combinations of signs.
some of them were. That one was, yeah.
Did you get feedback about how good you did, how well you did?
We didn't give them feedback. They knew a lot of times of how, as you all knew how well you did, and they could feel like they were getting better. But we didn't actually give them real-time feedback. Okay, so here's what we found. This is the results with the deaf guys. So they actually got better from the first to the third, basically. That was a significant difference between those two, and then they kind of flattened out. But there was no effect of visual feedback condition. And it turns out that there wasn't any difference between whether the visual feedback or not affected how well you produced the hand shapes or movements or locations. They were all equally affected. So here's the result with the hearing non-signers. So what's pretty interesting is they actually did worse with visual feedback. So with the normal vision, they actually did worse. They did better in both the blurry and the blind conditions. So there's a couple things that are not mutually exclusive in terms of what might be explaining this. One may be that when you don't have visual feedback, you don't have that mismatch between your own visual input and the visual input that you're trying to match. So that gets rid of that conflict. In addition, since these targets may actually be somatosensory and kinesthetic, that if you focus your attention on the somatosensory and proprioceptive feedback that you're getting by being blindfolded, that actually improves your articulation abilities. So if we come here, what I would suggest is that visual feedback may play a very different role, and certainly probably not a role in the same way that it does for auditory feedback in terms of fine-tuning your articulations. Now we have some other data that suggests that it's not completely irrelevant. So if you look, for example, at people who have Usher syndrome, which is a syndrome in which you're born deaf, hopefully you're exposed to a sign language. And then you lose your vision in early adolescence and adulthood, and it starts from the periphery. So you start losing your peripheral vision, and then you end up at some point having tunnel vision, and then becoming completely blind. For the guys with tunnel vision, they sign in a small space. So there's some suggestion that they may be signing in a smaller space to kind of keep track of where their hands are. But in addition, they may sign in a small space as a signal to the other person, because if I have Usher's syndrome, you have to sign in a small space, because if you're signing really big, I can't understand you because I have tunnel vision. Benzie Wohl has done some nice work looking at this population as well as normally sighted signers and measuring this. There's a correlation between the size of signing space and the size of their visual field. So there's something about visual input that wants you want to keep your hands there. But it doesn't look like visual feedback is being used to change your hand shape articulations or locations. Right.
But if you have a lesion like a homonosemia, the loss of visual field is scotoma in your signer, do you then go to the existing field and signal that to the person?
I don't know if there's been a case like that. With yeah, for comprehension. This is for comprehension production.
Yes.
Okay, so for things like neglect, you could fill in a lot. So even though there's some suggestion that even you still neglect that side of space, but the linguistic system and the language is often filled with redundancies, so it doesn't harm your comprehension very much at all. And for production, yeah. Well, it depends on, Usher syndrome is really severe. You really got to pinpoint, and that's when you see this change. But it's, I don't know. I think it's probably the safer answer. On the right side, yeah. Well, the key is what you show. So if you show things like, okay, this is the sign for father and this is the sign for dear, they know, even if they're neglecting this side, they know that there's something there, this has got to be the sign for dear. But if I make non-signs, okay, so it breaks the rules, but they know they break the rules, then they can't tell you what they see. So it's a little more subtle than just the languages, and you're still neglecting that part, but it's the language that's filling it in, right?
So one of the situations in which auditory feedback is perturbed is found in the Lombard effect. So if you're in a noisy environment, you change. You don't just speak louder, you speak differently.
Yep. So that's in a longer talk on this part, because we did that. We looked to see, so if you're blindfolded, we used motion capture, OptiTrack, to see, do you sign louder? So we had them shouting. And the answer is no. So it basically, blindfolded signing is pretty much indistinguishable from sighted signing. But there's other studies that if I can't see you, right? So now it's what you can see, then I sign bigger, right? But for my own signing, you don't get a Lombard effect.
Are there changes in the motor and somatosensory cortex between signers and non-signers, or I guess even new signers would be more interested to look at plasticity?
Yeah, so we're actually doing, I don't know if we'll end up getting it finished, but we're doing a study doing somatotopic mapping of the face and the hands, comparing signers and non-signers using puff severe. This is with Marty Serino's old postdoc at UCSD. And it looks like it may be these maps may be bigger on the left for our signers than for non-signers, but it's a good thing to look at. Okay, so let me see where. So what I want to suggest is that for signers, there's just a much more asymmetric dependence on this somatosensory, this internal feedback, compared to speech. So speech also has somatosensory feedback that is used, and you can show if you perturb it, you get effects. But there's just, for sign, I want to suggest that there's a much bigger role for this kind of feedback, and that the visual feedback plays a very different role than auditory feedback for speech. Okay. So actually, you know what? Before I come to just the summary conclusions, I want to come back to the stuttering thing. So I actually don't know much about stuttering, but I understand that one of the theories is that there's kind of a disconnect between sort of the auditory and motor systems, right? And so that's why delayed auditory feedback can work, is because you sort of change that system. So for signers, because there isn't this really strong correlate, dependence on sort of the visual feedback with production, so that signers basically in some ways are ignoring the visual feedback that they're getting, or at least not using it to parse their output, that you may not have the same phenomenon in sign, or it's going to be much less. So you're not going to see sign stutterers because you don't have that really super tight link between the visual feedback and the motor system. And we don't know. I mean, so to look, there's been only a few descriptions of sign stuttering, and it's more like repeating signs, so it's not clear what stuttering actually looks like. But kind of on this model, if stuttering comes because because you have this very tight link between perception and production in speech, and that gets messed up, and that's what's causing the stuttering, then you're not going to see the same kind of phenomenon in sign. So, all right. So let me come to what does this mean? So one thing is that it suggests that articulatory or somatosensory or a combination, but not this sort of external perceptual units are the targets for language production. Okay, so I kind of like some of the articulatory phonology views because they lend themselves so well to understanding sign language, and that it's not dependent on having an external perceptual target. Okay, so if you can explain everything in speech with that, it's nice because then you can explain sign languages as well. The other thing that this tells us is that within psycholinguistics, that this external loop for monitoring your language output is not universal. So in particular for Leyfeldt's model of word production, one of the ways you monitor your output is through the conceptual, through the comprehension system, through auditory feedback, which makes a lot of sense because you need a comprehension system to understand other people's speech. You can just use that same comprehension system to parse your own auditory output to catch errors. And for sign, you're not using the visual output in the same way. You can't use it to catch errors because it's not parsable in the same way that speech is parsable. So that's the internal loop. We have evidence for the internal loop for sign as well for speech, but the external loop may not be universal. So models that don't have to postulate an external loop, I would say, would support the sign language work. Okay. Uh-huh.
I guess I'm not following why it needs to be external perceptual as opposed to just a sensory versus a motor target.
Well, I put external there because what I meant. Because if I just said perceptual, somatosensory is perceptual as well. So what I mean is the external, so having an auditory target or a visual target, that's the parallel that I want to draw.
I guess I just don't see why internal versus external is the relevant comparison as opposed to motor versus sensory.
Well, I think the parallel is motor versus sensory. But sensory in this case has to mean, for the sign element, somatosensory and kinesthetic, that's the input and not the. So what's not universal is the external one. That's why I have that up there. So, but I mean, for models where that's really the be on and end all, it makes a difference because you really have to have it's an auditory target. It's not a somatosensory target. You have both, and it's the weighting, right?
But you need somatosensory target.
Right. Yeah. Right. So it's that's why I say it's the weighting. Okay. Then this, of course, then is going to have to play out in the neural system in some way, so that the fact that you have in speech, you have auditory outputs that feed to auditory targets that link to articulatory motor systems, that's a very strong loop. It's in these different models. For sign, it's not clear that you have that same link between visual output to visual targets to motor output. So you're going to have a different neural system for this kind of feedback for sign compared to speech. Okay, so questions on this part? Okay, I think I'm probably only going to get to the second part. So actually, I'll give you guys a choice. Because I can go through, well, let's just see, we'll go. Have another half hour? Okay. We'll see where we are at this, because I'll either end there for more questions or we can go to the next one. Yeah.
This is other topic, but I have been thinking it's related to emotional and social aspects, because I have two questions. First, in language acquisition, in hearing babies can discriminate sadness or happiness because of the eyebrows. How do they discriminate from hearing people doing these facial expressions? Do they show the same pattern? And the second question is, in general, we have spoken these little groups of students. How do they show emotional expressions, and how do these relate to social aspects?
So there's been a fair amount of work by Judy Riley and other colleagues looking at the development and use of emotional affective facial expressions and linguistic facial expressions, which are really different. They mark syntactic structures, they're often obligatory. And what she's shown beautifully is that you might think, in particular for things like negation, right? So head shake, right? Little kids, they get head shakes really early. Kids learning sign language sort of bootstrap from this early communicative gesture into the linguistic system and just sort of acquire these sort of negation, just opted into their linguistic system? And the answer is they don't. So they really, what happens is when kids first start producing grammatical negation, they actually don't produce the head shake. They produce non-manual signs like not first. And then, about a couple months later, they add the head shake, and then they have to learn to time it with the scope of the phrase. And that pattern carries over into other facial expressions too, so that you tend to learn the manual forms first, and then the facial expressions. So there's definitely a distinction between sort of acquisition and recognition of emotional and linguistic facial expressions. So did that answer your question, sort of?
At the same time,
Yeah, I don't actually know of a study that specifically looked at that. They're producing them at the same time. Adults, there's even some evidence that adult deaf signers are actually quite good at discriminating emotional facial expressions compared to non-signing peers. But do you know? Is Marie here? Okay. So I don't know if anyone's done that study. There's not a reason to expect that they would be different. Okay, so the next domain I wanted to look at is where there's differences between spoken language and sign languages, and that's how you talk about spatial relationships. So if you just want to describe cup on the table, what spoken languages tend to do is use a locative affix or a preposition to encode that spatial relationship. So all of you guys, I think almost all of the students are bilingual. At least maybe 60, 70% of you guys are bilingual in some other language. So think about how you would do this in your other language. How would you say cup on table, and what morpheme or preposition or affix you would use to encode that spatial relationship, okay? Sign languages are very different. There isn't a single sign that's used to mean in, on, under. Instead, it's where you place your hands in space. So this is a flat thing, this is a curved thing, and I can indicate that it's on by just where I place my hands, under, next to, floating above. So it's where I place my hands in space. So it's a different kind of system. Right. And within this system called classifier system, or, well, there's controversy about what you want to call it in the sign language literature, but I'm going to stick with classifiers for now. In these constructions, it's the shape of the hand that specifies a particular object type. So this is long and thin. I can change it to cylindrical, right? And this is drawn parallels to spoken languages where there might be a morpheme, in particular for verbal classifying languages where you have a particular morpheme like that means long, thin object. It can swap out with another morpheme like, I think, to in this case, that means curved object. And these have been called classifier morphemes that specify the type of object. And it's parallel to, or somewhat parallel to, the hand-shape morphemes that are used in sign language. And so what we wanted to do was to look at, to try to tease apart these expressions from the, let's see, what have I got now? So we wanted to know, how does this play out in terms of the neural systems that are engaged when you have to describe spatial relationships. And particularly we wanted to tease apart the location aspect of it from the classifier hand-shape aspect. So in this case, this was a PET study, and we had people describing, using these classifier constructions, the location of different, the location of an object that was in a variety of different places. So the clock is above, next to, under, on the other wall, leaning against, and you just had to describe where the clock was. So the object stays the same, but the location changes. And we.
But is there a difference between above and below? Because it could also be interpreted as the
Oh, yeah, so good, yeah, very good, yes. So in these studies, as well as in other ones, you have sort of a way of indicating figure and ground. So in this case, the ground was always the table, and you were indicating the figure with respect to the ground. So in this case, it wouldn't be the table under the clock because the table is always the ground, and it's where you indicate the figure. So the figure is the thing that changes. Yeah, no, that's very good. Exactly. So in this kind of context, because you're doing very similar kinds of labelings across the run, you don't have to each time say clock and table. But if you were in an actual conversation, you would need to, they're like proforms. So you need to specify that this is, I'm talking about the clock and not the window or something else that's around. So yeah, this is not like a full sentence. It's not a full sentence. It's sort of a part of a sentence. That's right. I mean, if you think of it in discourse, yeah. Okay. So we compared, so our hypothesis here was that these locations in space are actually not represented lexically. They're not morphemes that are retrieved from the lexicon. That really what you're doing is you're using space in a kind of gestural way. That is, you've got a gradient expression of location. You're not retrieving something like a preposition. Okay. In contrast to indicating something about object type, so in this case, the object, the location is always the same as on, but what changes is the nature of the object. So here now you're just indicating the type of object that's on the table. So sort of a generic thing or a cylindrical object, a long, thin object. Now these hand shapes are closed class elements, and these we hypothesize actually do engage the language system and do you do have to retrieve something from your mental lexicon, and these are stored. Okay, so we want to compare those two processes. Okay. So what I'm going to do, so that people were doing, we had some other conditions too that I'm not showing you. So here what I want to compare is neural regions that were more active for producing these location expressions than producing the object type expressions. And what we see is superior parietal activation bilaterally. And this actually replicates some other studies that we've done previously where it's not a continuous kind of gradient, but more just in, on, under. We get, when signers are producing these classifier constructions expressing location, bilateral superior parietal activation. And the idea here is that what we know about these, the functions of SPL has to do with being able to have a sort of a visual motor transformation. So if you see it in reaching. In this case, what you're doing is you have to transform this scene, objects in the scene, into a body-centered representation where your hands indicate the location of objects in space. And that's what we think is going on with this SPL activation. And this is different than what you see, as you would expect, for spoken languages that don't require that kind of visual motor transformation, right? So when you ask speakers of English to label spatial relationships in on the side, what you get is left parietal activation, supramarginal gyrus activation. It's true for comprehension too. And one hypothesis is that the reason in spoken languages you get this SMG activation is that the interface requires you to take this visual scene and categorize it in a way that sign languages don't have to do. You have to find the right categorical morpheme in, on, under, next to that maps onto that spatial scene. And that is what's hypothesized to be involved in this SMG activation. For sign, that's not what's going on. You have a much more gradient kind of mapping between either your mental image or the scene that you're describing and the linguistic expression. Okay? Then when we do the opposite contrast, so now we're looking at regions that are more active when you're expressing the classifier hand shape, the object type, compared to location. What we see is first this left IT. So if you remember back to the beginning of the talk, this is a region that seems to mediate between object recognition and lexical retrieval. So you have to recognize the object and retrieve the correct hand shape that goes with that object. Okay? Yeah. And we also see left inferior frontal gyrus more active for producing these. So again, this region is involved in all kinds of functions, but in terms of what we're seeing here, lexical selection, lexical retrieval of the correct hand shape for this given object. So we see this left inferior frontal temporal regions engaged for expressing these classifier morphemes, but we don't see it for the spatial location expressions. Okay. So what does this mean? Well, one of the things it means is that for sign languages, you have a very different type of computation when you're producing spatial language than you do for spoken languages. Okay, you have to do this visual motor transformation from either sort of an image of what you want to talk about or a scene you're describing into this body-centered representation. It's not something that spoken languages have to do. And these expressions can be quite gradient. So they're not categorical in the same way that prepositions are or locative affixes are in spoken languages. Okay. I feel like there was something else I was going to say about this, but I don't remember what it was. Yeah, so, I know what it was. That this is not something that's just true of American Sign Language. So, in fact, there are no sign languages that I know of that use prepositions or locative affix or these closed class morphemes to encode spatial information. You can have these morphemes, but they tend to be used not in everyday spatial descriptions, but things like for labeling or for emphasis. So when you look cross-linguistically, sign languages use, because they use what resources they have. Their hands can be placed in space, and they use this mechanism for spatial descriptions. Okay. Okay. So, yeah. Oh, I forgot to mention this.
The right hemisphere lesion patients were impaired at interpreting sentences that indicated the spatial locations of objects, and the left hemisphere patients were impaired on understanding the grammar of the sentence. So how does that fit with your kind of bilateral activation for location?
Yeah, so that's a great question. So I think we haven't probed exactly what the two hemispheres are doing, but it's quite likely that the right hemisphere is involved more in the actual getting your hands in the right locations, targeting, and this kind of thing. Whereas, the left hemisphere may be involved in that as well. But we know that the left hemisphere also is going to be involved in the linguistic processing of these. So what I mean by that is, I always get into trouble when I present this because it looks like it's really simple, right? That, you just put your hands where they are in space. But in fact, there's all kinds of linguistic constraints on how that works that you have to learn. So, for example, this is the ASL sign for vehicles. This is an ASL sign for someone standing. But if you wanted to talk about someone standing on the roof of a car, this is not, you can't do this. You have to use a surface-based kind of thing. So it's a rule you have to learn. If you want to say someone got into a car, so this is seated person, this is the car, you don't do this. This would mean they're sitting right next to the car. You have to do this kind of movement to show that they got into the car. So you have the same final endpoint, but depending on the movement, it's whether they actually got into the car or they're sitting next to the car. You have to know what orientation is unmarked. So there's all of these kinds of constraints on exactly how you use these classifier constructions. It's likely the domain of the left hemisphere. So when we look at patients, it doesn't fall out as neatly as you might think, where, okay, locations, you find damage with right hemisphere and hand shapes with left hemisphere. You see, in fact, both groups are impaired in the production of these classifier constructions. So it's not just the right hemisphere damaged patients who are bad at these classifier constructions. Both groups are. So that sort of fits with a bilateral representation. Okay. So I think, it's up to you guys. I'm open to asking, if people have other questions about sign languages, we can sort of open it up for there, and I can just go to my conclusion slide since there's only about 15 minutes, or I can...
What was the third point?
Oh, sorry. You don't remember. The third thing was looking at language in action. So this is looking at the distinction between verbs that look like gestures and verbs that don't. So this dissociation between pantomime production and verbs that look like pantomime production and whether they engage the same neural systems. You want that? All right. All right. So this comes up because, again, it's the biology, right? So it's very hard to make a word sound like something, but you can make a sign look like an action, a particular action that involves an implement. Okay. And so here's some examples. These are handling verbs. So the verb scrub looks like scrubbing. Okay. The verb to drink looks like how you would pantomime drinking. Okay. So the question is, are there ramifications for how verbs are represented and how they're produced when they have this complete overlap with what pantomimes look like? So not exactly. So there's lots of these handling verbs you see across sign languages, but exactly what gets lexically encoded might be different. So for example, the ASL sign for screwdriver looks like this. So in this case, what I'm doing is I'm showing you the instrument that's moving, right? But in another sign language, I don't know what it is in BSL for screwdriver. It might be, so in BSL, it's more of a handling sign. So whether you sort of have a more instrument-like gesture or more handling-like gesture can vary across sign languages. So the exact form of that can differ too. So you could have it like this or like this. So it can be lexically specified. Okay? And that's the difference between pantomime and for sign. So in pantomimes, it's the properties of the objects. They're going to determine what the gesture looks like. So if you're drinking from a cup versus a straw versus a shot glass. Whereas for sign, this verb for drink can be used regardless of what kind of thing you're drinking out of. It has a phonological specification, a semantic specification for, imbibe liquid, but it looks like a pantomime. So what we know about pantomime production is that when you ask hearing people to produce pantomimes, you tend to get left lateralized SPL activation involved in sort of motor planning, motor actions. You don't see activation in language areas necessarily. In particular, you don't see strong activation in left IFG when you ask people to pantomime, but you see activation in SPL. So when you think about, that we have these verbs that look like pantomimes, one question is whether or not these signs pattern like pantomime. And if so, you might see then that you're going to get greater activation in superior parietal cortex for those signs. On the other hand, if they pattern more like spoken words, then we're going to see language areas, in particular left IFG, active when you're generating verbs as opposed to pantomimes. So what we did was this is again a PET study. We had signers produce verbs in response to manipulable objects. So just produce a verb that goes with that object. We also had both hearing and deaf groups produce a pantomime. So again, they would see these manipulable objects, but now show me how you use this. And then we had a baseline condition where, again, you're seeing manipulable objects, and you're asked to make a gesture about whether or not it can be held or not. And I'll show you each of these, what these look like. So in the verb generation task, we had two sets of objects that were normed on a separate group of signers, where one set of objects elicited iconic, these handling verbs, and another set, again, manipulable objects, but they elicited verbs that didn't have this iconic property of being a sort of pantomimic-like. So here's what the objects look like that would elicited handling verbs. So the sign for write looks like this. The sign for hammer. Oops. Like that. Okay. And this could be contrasted with verbs that were non-pantomimic. So if you see a picture of a ruler, the likely verb that was produced was measure. Like that. And this is my favorite one in ASL, pour syrup. Like that. Okay. All right. So this is the verb generation. So the idea is if these pantomimic verbs, if the pantomimic verbs really engage sort of pantomime regions, you should see more activation in SPL for those verbs than for these verbs. So then in the pantomime case, we had non-signers do this. They also produced pantomimes for those handling verbs. So the ones, the pencil for writing and the hammer for the ASL sign hammer, our hearing people saw those same pictures, but were asked to show me how you use the object. So what they produced looked very much like what the deaf signers produced, but for the deaf signers, they were verbs. And then we had a set of objects that both groups produced pantomimes to. So in this case, producing for, you see broom, and you produce a sweeping pantomime. Now, in ASL, these are good. Now, the ASL sign for sweep is this. Okay. So we chose these so that the signers couldn't kind of cheat and produce signs. So the signs that would go with these verbs don't look like the pantomimes. So for this, if you would sort of pantomime eating, I mean, the verb would look like this. So, yeah. Well, that's part of being a model in these experiments. But, okay. So what do we see? Oh, so then the baseline task was you see lots of these manipulable objects, and you sort of do this if you can hold it, and you do this if you can't. So you're getting sort of this motor response. You're thinking about the manipulability, but you're not generating a verb or generating a pantomime. Okay. So here's just looking at the deaf guys pantomiming compared to that baseline. And we see SPL, which is what we expected. It's actually bilateral and more extensive than what we see for our hearing pantomime producers. And what we think might be going on here has to do with sort of the expertise of deaf guys in pantomiming. So they produce more complex pantomimes than our hearing gesturers. So if you were producing a pantomime for stirring, a hearing person might just do something like that. But a deaf person actually represents the cup as well as the spoon, or as a stirring action. So they tended to have more two-handed productions. Their hand shapes tend to be crisper. They tended to repeat the pantomime compared to our hearing guys. So it's possible that what we're seeing is sort of a richer representation, as well as more motor movements in the deaf than in the hearing gesturers. But the key was what happens with these handling verbs. So these are now the signers are producing verbs in response to these manipulable objects. And what we see is sort of classic area active, so actually BA47, BA45. This is exactly what you see when hearing people are asked to produce verbs to pictures in English or in other spoken languages. But if you look at the hearing people, now they're seeing the same pictures, but they're producing pantomimes. We don't see activation in left IFG. In fact, we see this SPL activation that looks exactly the same as the SPL activation in the previous slide. So then finally looking at, let's compare these pantomimic verbs with these non-pantomimic verbs. Do we see any difference in neural activation? Do we see greater activation in SPL for the handling verbs than the non-handling verbs? And the answer is no. So this is just a picture of the pet palette. So if we were going to see, you should see red areas that would be significantly more active for handling verbs, or purple areas more for the non-pantomimic, more activation for the non-pantomimic verbs. But everything is pretty much green, which means there's just no difference between those two verbs. And this replicates another study where it was action naming rather than verb generation. And again, when we look at these pantomimic verbs versus non-pantomimic verbs, there's no difference between the two. So this is telling us that, verbs and pantomimes are different, right? They're non-identical. So when you look at signs, you get left IFG involved in lexical search and retrieval. Even if you're producing something that looks exactly the same, but it's a pantomime, you get SPL, activation, bilateral, and no difference between these iconic and non-iconic verbs. So the brain is sort of treating these as verbs. They're not treating them as pantomimes. I want to be a little bit careful in terms of it's not the case that there's no overlap at all between sign production and sort of gesture production. But we do see this dissociation here, and we also see a dissociation within the aphasia literature, where you can have an aphasia with pantomime preserved. But we don't see the reverse, so there isn't a double dissociation. So we know of no cases in which you have spared sign, you're fine with sign, but you have impaired pantomime. Right? So there's some connection between the two. All right. So some take-home messages. One is that auditory, vocal, and visual manual languages exhibit common structural properties and computational systems. So this is why it's interesting to look at sign languages, right? Because the evidence from linguistics, from psycholinguistics, suggests that we really do have very similar linguistic and psychological systems. Okay? And because we're sort of starting, we do have apples and apples, we can start now looking to see, okay, well, given you have these different linguistic articulators, different perceptual systems, how do sign languages interface with other systems, human action systems, with spatial cognition? Is that interface different for sign language than for spoken language? And what does that tell us then about the interface for spoken languages? And these sensory motor differences may turn out to have these interesting implications for the differences in neural substrate that are non-obvious. So it's not just the case that, well, of course you use the visual, it's perceived visually versus auditorily, or different linguistic articulators. We see this in feedback processes, something that I don't have time to talk about, but we see when we look at sign versus speech comprehension, you see really big differences. And in particular in parietal cortex, you see the parietal regions being involved in sign language comprehension to a much greater degree than you see for spoken language comprehension. And and also for production. So if there's a sense that production systems are being used in comprehension, there's some interesting models out there now. Martin Pickering is really pushing sort of the use of production in comprehension systems. If you have a very different production system, it's going to affect what your comprehension system is like. So we may see some differences in terms of how the neural regions that are involved in, say, forward model predicting for sign comprehension compared to speech comprehension. And that's it.
So we have 5 minutes for questions from G. Oh. I have two quick very beautiful work, but I've one conceptual question, which is that on the one hand you say, well, at the computational level we can see that there is structural overlap between the spoken language and the sign language. Now the question is at the neurobiological level, because of the fact that there is, at least for the congenitally deaf people, the auditory cortex is not getting the input. And just as Marina Bettin's work showed that, for instance, in congenitally blind, simple cortex all of a sudden starts to become involved in certain high-level aspects of language processing. The question is whether the comparison is not handicapped by the fact that this particular infrastructure in which the system is implemented is quite substantially changed as a result of the
lack of that particular type of input. And that makes the direct comparison more complicated. In that case, I'm interested to hear whether if you do bilingual subjects who are hearing subjects, whether you get the same results as what you see when the congenitally deaf.
Yeah, so in fact, that's what you look at. If you want to avoid that problem, you look at the bilinguals within the same person, and you see very similar results. There's
so none of the results that you showed is affected by the fact that they're
not too much. There's a few differences that we know of that are a bit different. One is one that Emmorey discovered, which is looking at within auditory cortex. For the hearing signers, you tend to have more posterior activation. It's the same activation as the deaf, but for the deaf, the activation tends to extend more anteriorly into auditory cortex, closer to primary auditory cortex. Whereas it seems like for hearing signers, that region may be sort of preserved or preferentially respond to speech and auditory input. One other difference we see is really not related to something interesting, but it's related to language competence. So hearing bilinguals tend to be dominant in the spoken language because they're surrounded by the spoken language. So when you compare, for example, just sentence processing with deaf signers, you tend to see a little bit more activation in left IFG compared to the deaf signers. But it's similar to what you see when you look at less proficient speakers to proficient speakers. Less proficient speakers tend to have more activation in left IFG than proficient speakers. But in general, you don't see a huge difference between, I mean, you can step in if you have a different viewpoint.
I think we can look at those hearing bilinguals to pull apart the two factors. What's the influence of deafness and what's the influence of sign language knowledge? Lots of studies have done that. But in terms of the things that Karen's talked about, they all stand in hearing bilinguals. Yeah. But of course there are effects of deafness, and there is some level of interaction, but actually less than you might think.
Because it's well known that like peripheral vision is better in deaf. So if you would the degree to which visual feedback can be let's say recruited, you would expect some difference there because of the fact that there is more.
It's turning out that some of the differences in these kinds of peripheral things and other kinds of visual responses really seem to be tied to deafness, not so much to sign language experience. But it's in these sort of non-linguistic domains where you see that.
Because where they're looking at out here, where the differences are, you don't sign out here.
Right.
So in terms of sign language processing, you wouldn't expect to see that.
I was just wondering, what would you expect to see in terms of, would there be a fair amount of overlap or not much overlap, comparing deaf people doing sort of iconic pantomimes and hearing people making kind of iconic noises versus deaf people doing pantomimic verbs and hearing people doing onomatopoeia?
Yeah. So the difference between, sign languages allow for a lot more iconic expression than spoken languages. So you just have more resources. It's much easier to make the hands look like the actions than it is to make something sound like a referent. But people are looking at that. There definitely is the potential in the spoken language modality to do this kind of onomatopoeia and have this kind of mapping. So in fact, I was just at this gesture conference where there was a presentation on a guy who he got speakers together and they couldn't speak and they had to communicate these different concepts to their partner, and they had to sort of create these sound meaning mappings, and they played this a couple rounds, and then he played their final productions to naive people who had to guess, and they were pretty good at guessing. So it's possible. Now, he, of course, picked the concepts, he said sort of randomly, but it's, so there are going to be things. So, but I think in terms of the resources, you just have more resources in sign languages.
Well, but so theoretically, you also chose objects to give pantomimic, representations for that were clearly representable.
That's right.
So the items are as controlled or as not controlled as you want to make them. I
sort of a part of our neural systems that's kind of dedicated to this idea of retrieving semantic information and kind of processing what's iconic versus what's language and kind of teasing apart where our semantic system feeds into each of those processes before we get down to the nitty-gritty of I'm sending this message to my hands versus I'm sending this message to my mouth.
You had me up into the last part.
So, like, obviously there are going to be motor differences and where
I
you're
see,
sending
okay.
the eventual signal to make either the gesture or the noise. But up until that point, I wonder if there might be a certain amount of overlap in terms of the processing that you would need to arrive at something that you think would be iconic enough to send the message you want.
Yeah, I mean, I think there are parallels, certainly between the creation of iconic expressions in spoken language and the creation of iconic expressions in sign languages. The differences are a little bit in terms of the evolution of the languages, right? So sign languages are much closer to their gestural roots, and so you can kind of look to see how early iconicity is represented and how it changes over time. It's harder to see that in spoken language, but it's clear that there is something that preserves certain aspects of iconicity. So a kind of famous example is that the English word peep, what a bird says, didn't undergo the great vowel shift because it would have become pipe, right, which is not what it sounds like birds say. So there are certain things that end up getting preserved. On the other hand, other kinds of things reduce iconicity, and it can be really fragile within the sign language system, so that other pressures like articulatory ease or a morphological system can disrupt the iconicity. So there's actually a lot of work going on right now to try to figure out the role of iconicity in language processing, both in speech and in sign. And I have a whole other talk on that.
So is there any clear distinction in sign language deficit between production and comprehension, like those who can sign but cannot comprehend sign and vice versa?
One of the things that I meant to say that I forgot, which has to do with just the lesion studies. So you can get the same kind of relative difference. So when you have frontal damage, you tend to have non-fluent aphasias with relatively good comprehension. And the same thing with when you have damage to posterior temporal regions, you have fluent production but relatively poor comprehension. So in that sense, you can get those dissociations. Yeah, no, I said relative. And I did this gesture. Oh.
Clear distinction between them.
I mean, you can have the sign version of pure alexia, right? So the idea that you can, so that in spoken language for reading pure alexia, you can write perfectly fine, but you can't read what you've just written. That's my understanding that there's also a sign language form of that you can produce sign perfectly fine, but you can't actually process it, whereas you can process gesture perfectly fine from a visual.
Oh, that I don't know. Greg Hickok has a paper on he calls it sign blindness, but they didn't test that he could perfectly understand gestures.
The paper I'm thinking of by Greg Hickok, that's in 1996. I think it also has Luigi on it. That's what I'm thinking of. Maybe I'm misremembering it.
Well, there's a paper on sign blindness. What I don't remember is if it was distinction. I mean, it was basically you aren't seeing this input, so it's sign blindness, right? But it's not specific to sign. I don't think he compared sign to pantomime, for example, or something like that. But I could be misremembering his. Yeah. Do you some? Yeah.
Last question.
Can I do two very quickly? This is back to the question of the visual feedback. When babies are sign babbling, do they also babble like this? Or
Oh, I actually worked with Laura Ann Petito for a little bit to try to see if we could analyze some of her baby babbling down to see if they looked at their hands more. But we don't know. We don't know whether they are doing something like this or not.
The other question was about stuttering. One of the hypotheses we heard today was that there's a kind of mismatch between motor activation and planning, such that the planning hasn't been fully completed before before the motor system goes off. And it seems like the relative absence or complete absence of stuttering in sign would be an argument against that, because that could clearly happen in sign.
Yeah.
Whereas the auditory, the sort of mismatch between the auditory feed-forward model, et cetera, that other thing that we were talking about, clearly is a difference.
Yeah, the problem is it's not a knockdown, drag-out argument, in part because the relevant epidemiological kind of, studies haven't been done to find out, okay, well, really well, first of all, you have to have a good definition of what stuttering is that parallels stuttering in spoken language. And you probably come up with something that would work, and then do the right sort of survey to find out, okay, what is the actual incidence of stuttering in signers. So it's a hard study to do.
But given how many signers there are in the world now, and given how rare it seems to be, don't you think that already, if it's not, it seems relatively rare.
Speaking might be much more complicated not to act than signing, and I'm speculating at the moment. That could also be a difference, right? So the precise temporal characteristics and all the factors that need to be involved in order to produce it.
Because it's quick. I mean, the articulators are slower.
Mean rate of signing.
Yeah, we were talking about this before.
So,
How would you quantify?
yeah, I know you've asked me that before. So, things like just hand shape change, it's about 250 milliseconds. But that's yeah. So but the internal kinds of things. So for speech, you've got changes that are happening on the order of 30, 40 milliseconds. There's nothing like that in speech. I mean, in sign. So in terms of that transitional.
So yeah, rather than saying more complex, I would say
Granularity of the temporal plan.
more timing dependent.
Yeah.
Well, and I mean, articulators are confined into a much smaller space, and the movements have to be a difference of a fraction of an inch can make a really big problem when you're trying to speak. That's probably easier to overcome when you're using your hands.
Well,
Move something out of the way if you overshoot with something else, whereas you can't move your hard palate if you're overshooting with your tongue.
Yeah.
On that note,
We need some keeping your palates in place.
yes.